Okay, so if you remember, before I begin the class, if you remember, to recap back what we have learned in chapter 5, we have basically learned how to convert the experimental data, okay, that we obtain from the lab. And then from this experimental data, we would like to find the two important information, which is finding the reaction order, alpha, and also finding the reaction rate constant, K. So why it is in one whole chapter, because as you know, we have different method that we can use. So I already discussed as well what are the pros and cons of each method. Okay, so why we have a differential method, we have integral method, we have half-life method, and why what are the pros and cons of each method, and the basis of selection of which method you want to use. So certain methods can be a bit tedious in terms of conducting the experiment, but the equation is simpler to be applied, or the experiment can be quite straightforward, but for you to obtain the data, the equation can be a bit complex. And as you remember, I taught you we need to plot a graph. We are finding alpha and K based on the basis of plotting a graph. From the graph, we interpret the intercept, y-intercept, we interpret the gradient or the slope in order to obtain that two information. Okay, so in today's tutorial question, as you can see from the question, the plot is already provided for you. So meaning tutorial ni kita just interpret the plot, how we get the information from the plot to solve the questions. Okay, but in test and exam, do prepare that maybe you'll be asked to plot the graph. Okay, so kalau kamu kena plot the graph, kamu kena tahulah how do we obtain the data for the y-axis, the data for x-axis. We plot the graph, and for the graph, we synthesize the information to solve the question. Okay, so as I told you, you are free to use any software. Usually we use Excel, so make sure you're familiar lah how using Excel to plot the graph in order to synthesize the information. Okay, just like in this tutorial, the graph is already provided for you. You don't have to plot. Okay, so let us see the questions for tutorial chapter 5. Right, so the first question, the irreversible isomerization liquid phase reaction was conducted in a batch reactor at 50 Celsius. So the very first information, okay, this is a liquid phase. Please remember that you really need to understand the phase of your reactants. Okay, it's very important, as well as the temperature. So the temperature is mainly affected, as I told you, the value of K, because the value of K will change with temperature as ascribed by the Arrhenius equation yang kita pernah belajar dulu. Okay, so the following concentration time data was obtained. So you imagine you conduct this experiment in a batch reactor at 50 Celsius, and from the experiment, okay, so imagine at minute 0, you started with the initial concentration of 4. So means your A2, you start the concentration 4.0 mole per dm cube. So that is your Ca0 lah. Okay, so then the next 2.5 minutes, you take up sample, you measure the concentration, it became 2.89. So the next 5 minutes, minit kelima, you take out sample, you check concentration, 2.25. Okay, so by now, logically, you should be able to understand that definitely the concentration of A will decrease with longer time. So why it decrease with longer time? Because A will be consumed during the reaction. So next time, kalau let's say like, I think probably by next semester you will do FYP. So let's say you're doing FYP, something related to reaction. This is a very important understanding yang you kena faham. So let's say you are taking up samples every minute or every subsequent minutes. The fundamental is your reactant concentration must decrease. Okay, means kalau dia decrease tu means adalah tindak balas yang berlaku and your A is consumed during the reaction. So let's say you have the reactant, okay, you react the reaction, then let's say you check the sample, the concentration doesn't change. Kalau concentration doesn't change, means tindak balas tak berlaku lagi. So you have to check lah what happens, right? Okay, so that's the start story. Right, it says, the following plot of a ln negative dCA per dt versus ln CA was obtained from the data above. Okay, so imagine now, good enough. In this question, you don't have to plot the graph. Okay, remember I taught you last Monday, kita nak kena plot graph dulu kan? So question ni you don't have to plot. The graph is already given to you as shown in this plot below here. So you can see the y-axis is ln minus dCA per dt. Your x-axis is ln CA. Okay. From the plot, the gradient was determined as a 0.65 with a y-intercept of negative 1.65. So first, they give you information pertama yang paling penting. They tell you the plot of x-axis and y-axis tu apa data dia. Second, they told you about the gradient. So you don't have to measure the gradient. You don't have to calculate. It's already given as 0.65 and the y-axis intercept negative 1.65. So that's all information that we have from the plot. Okay, so let us try to see the questions. So the question says, determine reaction order and the activation energy in joule per mole. Given frequency factor as 200 per minute. Okay, so in order to start this question, as I always keep repeating during tutorial, and it's actually applicable to all engineering problems, knowing where to start and knowing, of course, what to solve lah kan. Okay, so I always told you nak tahu where to start is first knowing what equation is relevant ataupun possible untuk digunakan. Okay, so in this case, right, so you fortunately enough, we just learned chapter 5. Okay, kan we learned that we have different method that we can use to elucidate atau to obtain the reaction order and to obtain K. And then the different methods are because the different equation. Okay, so for in this case, the first challenge is nak tahu equation mana nak digunakan. So in order to know the equation, you have to know the method first. Okay, so how do we know the method? So you remember I told you why we have different methods about different equation. So now the problem here is that you have to then determine, okay, from the plot which method. So kalau you dah tahu method from the plot, then you will know the equation. Okay, so for last Monday I taught you we actually learned 3 main methods. Yang method yang last tu not so it's just a knowledge. We don't cover it that much. But the 3 main method that we will cover is differential, integral, and half-life. Okay, so definitely half-life tu dah keluar because if it's a half-life method, data dia mesti in the form of half-life. Okay, so you have learned, right? Half-life 2 is not the same as reaction time. And half-life is the time needed for the initial concentration to become half of its value. So evidently, this is not half-life data. This is time and concentration. If time and concentration, we only have the other 2 methods, either differential method or integral method. Okay, so then if you remember, this is definitely a differential method equation. Kalau pun kamu tak sure, kamu tengok dia kan ada dCA per dt. dCA, the D is to signify is a differential sign. Okay, so this is differential method. So once you have established it is differential method, therefore you go and check. What is the differential method equation? You have to first find out, dah tahu differential method, what is the equation? Okay, so if you remember, the equation for differential method, the equation is ln negative dCA per dt equals to alpha ln CA plus K. So this is the equation. Okay, now next step is, okay, so means from this equation, I can get my alpha, I can get my K. Okay, so check back again. If soalan, the question wants you to find reaction order. Reaction order tu alpha lah. Okay, so betul. Means equation ni saya dah boleh solve alpha. Okay, the next one, the question wants activation energy, EA. So you might wonder, dia nak cari EA, but my equations tak ada EA. However, my equations ada K. So ln K essentially. Okay. So hopefully you understand the correlation. You remember the correlation. We can find EA if we know K using Arrhenius equation. So meaning in this question, in order for me to find activation energy, I have to first determine the value of K. So means since both of what the question wants, the both unknown that the question wants can be solved through the equation. So this verify that this equation can be used to solve the problem. So the next challenge is how to use the equation. Okay, so kamu kena faham. Okay, I taught you equation ni is always in the form of y equals to mx plus c, because I would like to plot a graph with a straight line. So kamu belajar kan, kalau kita nak plot graph straight line, equation dia must be in the form of y equals to mx plus c. So evidently from the plot you can see that the ln negative dCA per dt represents y-axis data. Okay, so naturally, your ln CA will represent the x-axis data. So ln CA become x-axis data. So naturally, your alpha will be your gradient. And naturally, your y-intercept, the C, is your ln K. So that's how you synthesize daripada equation. Okay, you know what's your y-axis data, what your x-axis data. So the gradient should be your alpha, your ln K should be your y-intercept. Okay, so from the question, they do give us the gradient. The gradient is 0.65. Keturunan graph tu adalah 0.65. You can see this is a positive slope. Okay, so I hope you still remember when you learn mathematics kan, kita tahu kalau keturunan negatif, how the plot should look like. Keturunan positif, how the plot should look like. So this is definitely a positive slope. That's why you have a positive gradient. Okay, so we learned that the gradient M equals to alpha, your reaction order. So it's equal to 0.65. However, I taught you, you have to round up to the nearest integer. Okay, so 0.65, if you round up, it becomes 1. Ataupun we can say it is first order. Sebab alpha tu kan reaction order. So normally we will say 0 to 0 order, 1 to first order, second to second order, or 3 third order, or 4 fourth order, so on and so forth. So in this case, 0.65, the nearest integer is 1. Ataupun we can say it is a first order reaction with respect to A. So, if you want to write the rate law, let's say kamu nak tulis rate law, okay, so the rate law become minus RA equals to KCA. So, why KCA? CA power of 1 is still CA. So, we can just write it as KCA. So, although the question doesn't ask you to find the rate law, but you can actually write it out dah sebab kita dah tahu the reaction order. So, next one. Remember, we want to find ln K. We want to find K, sorry. So, from the equation, your ln K is your y-intercept. So, ln K equals to y-intercept is given as negative 1.65. Okay, so this one I hope you still remember. Kalau kita ada ln K, on your left is ln K, on your right is number. In order nak hilangkan ln di sebelah K tu, so K become exponential number. Okay, so bayangkan kalau ada ln K, ada nombor. Kamu nak matikan ln di sebelah kiri, kamu kena exponentkan kedua-dua belah. You have to take exponent on both side. So, exponent ln K jadi K, sebelah kanan jadi exponent negative 1.65. So, by right, when you do this, you will get your value of K as 0.19. Okay, so temperature dia 50 kan? Okay, so your K value is 0.19. Okay, so then if you remember, I taught you the unit of your K, you have to deduce based on what you learned in chapter 3. So I taught you in chapter 3, chapter 3 ke chapter 2, something like that, chapter 2. Chapter 2, you have learned that we can deduce the unit of K depending on the reaction order. So if it's 0 order, the dimension for the K is concentration per time. So example, mole per liter minute, okay, mole per dm cube second. Kalau first order, dimension dia per time. So, the unit can be per minute, per second, so on and so forth. So, dalam kes ni, why do I write it per minute? How do I know? Saya tahu dimension dia per time. Tapi unit dia, macam mana saya tahu dia adalah per minute? So, how do you know? Check back your experimental data. Experimental data, the unit for time is minute. Hence, that's why saya guna per minute. So katakan kalau eksperimen saya, I measure in second. So my unit become per second. So the dimension kamu tahu per time. Unit dia kamu kena refer back to the experimental data. What are the unit of time that you use? So that become the unit for your K as well. And if it's second order, the dimension for K is 1 per concentration time. So example unit liter per mole second, dm cube per mole hour, or kalau empirical engineering unit, feet cube per pound mole second, something like that. Okay, so the unit is really depending on the reaction order. Okay. However, you cannot just stop over there because dia nak kita cari EA. Although you already have K, tapi you haven't answered the question. The question wants you to find EA. So by now you're already familiar, right? We already learned Arrhenius equation. In fact, we use so many times that it's something that you're very familiar with. Okay, so again, I always keep emphasizing this because this is the most important thing that we always have to understand bila kita nak solve problem. I have one equation. I know what my one unknown that I want to find, which is EA, meaning the rest of the unknown dah kena ada nilai, must have a value. So as long as the other unknown you don't have value, you cannot solve the question and you don't attempt. It will be a waste of time because takkan dapat di solve if you have more than one unknown in one equation. So for this example, meaning the rest besides EA must have a value. So first of all, K. So K, from the plot information, we have already determined K. So K 0.19, done. So next one, A. A is pre-exponential factor. So in the question, ataupun we call it frequency factor. So sometimes we call it frequency factor, sometimes we call it pre-exponential factor. It is still the same meaning. So the A is 200 per minute. Okay, so next one, EA I want to find, so I leave it. Okay, R, gas constant. So gas constant, in this case, you have to be very careful sebab we have two gas constant, right? Either 1.987 calorie per mole Kelvin or 8.3144 joule per mole Kelvin. However, in this question, they want in joule per mole. So automatically, it will be 8.3144 joule per mole Kelvin. Don't forget, in this Arrhenius equation, we have a negative sign, negative. A exponential negative EA per RT, because sometimes in questions, student has the tendency to forget the negative sign in front in the Arrhenius equation. Okay, now next, temperature. So we know the reaction is conducted at 50 Celsius. The question mentioned the reaction is at 50 Celsius. However, don't forget, some student might have tendency to forget the temperature must be in Kelvin. Purely because your R value tu dalam bentuk Kelvin. The unit of temperature, the unit of the temperature in your R value is Kelvin. So you have to change the Celsius to Kelvin by adding 273.15. So when you solve this, you're able to get your activation energy as 18,697.56 joule per mole. Okay, so that's to solve for question number 1. Okay, so I will go to question number 2. Then I will give you a little bit of break to attempt the question. Okay, so question 1B. Sorry. Determine the rate of disappearance of B at 15 minutes. Okay, so kalau kamu perasan, this question I didn't cover in chapter 5 kan. Bila saya bincang pasal chapter 5, I always teach you until cari alpha, cari K. Tapi I never teach you about, kenapa tiba-tiba the rate of disappearance. Tetapi you don't forget, this is something you have learned in the very first chapter. Chapter 1, kita dah belajar mengenai rate, right? Rate of disappearance, rate of formation. So this is an example of a question where you are asked again benda yang kamu dah pernah belajar dalam chapter 1. So you must remember reaction. You cannot learn the chapter in isolation. The chapters are actually related to one another. Tapi kenapa? Sebab each chapter ni is to build the understanding to design a reactor. So dia bukannya separate chapter. Chapter ni adalah chapter yang it builds from one another sampai kamu dah faham, dah sampai boleh design reactor itu. Okay, so dalam kes ni, they want to find rate of disappearance of B. Okay, so B is a product, right? Okay, so dia nak cari rate of disappearance. So if you remember, rate of reaction ada dua jenis kan? Ada rate of disappearance, rate of formation. What's the difference? Rate of disappearance, negative R. Rate of formation, positive R. So in this case, they want us to find negative RB. Okay, so nak cari negative RB, saya pun dah pernah ajar. And kamu pun dalam test 1 pun kamu dah buat. Okay, kamu dah pernah ingat kan? Kita nak cari the rate of other reactant or other product of basically any other compound punya rate, kita tak boleh cari until we know minus RA, which is the rate disappearance of A, which is the rate law. So kenapa? Sebab kenapa kita kena cari minus RA? Sebab rate law kita tu berdasarkan minus RA. So remember we learn the first order ke, second order reaction ke, untuk kita tulis rate law dia. So the rate law tu is always based on minus RA. So means kalau dah tahu minus RA, then only you can find the rate of other compounds in the reaction. So we have to first find minus RA. Okay, saya cari minus RA. So dia kata, so kita cari pada 15 minit, at 15 minutes, the rate of disappearance of B at 15 minutes. So naturally means kita pun kena cari jugalah minus RA at 15 minute first, then we can get minus RB at 15 minute. Okay, so to find minus RA, you just remember kita cari the rate law. So rate law we already find in part A, right? So the rate law is KCA. Okay, so K we get from part A, the K that we calculated, 0.19. So what about CA? Sebab CA ni mesti apa? CA must be the concentration of A at minute 15. Sebab dia nak cari minus RB dan juga minus RE at minute 15. So the CA must be the concentration of A at the 15 minute of the reaction. So how do we do this? Okay, so what you do is you just look at the experimental data. Experimental data dah beritahu kita dah. What is the concentration of A at the reaction at the certain time? Okay, so at minute 15, the concentration of A is actually 0.25. Okay, so I will just replace CA as 0.25 because that's the concentration of A at minute 15. Okay, so then I will get my minus RA as 0.048. However, we are not yet finished. Okay, sebab kita nak cari minus RB. We only just finished finding out minus RA. We have not yet found minus RB. Okay, so you have to remember back dalam chapter 1, I taught you the correlation between minus RA to the other compounds. Okay, so in this case, they want you to find minus RB, rate of disappearance of B. Okay, minus RB. Then you remember the number can be positive or negative depending on the species role in the reaction. So what do I mean by that? In this reaction, B is product, B is form. We want to find rate of disappearance of B. However, in the reaction, B does not disappear, B is formed. They don't agree to one another. That's why there's a negative sign in front of the number. Okay, again, I repeat, the number, you must find the rate, okay, either disappearance or formation. The number can be positive or negative depending on whether the compound disappear atau form. Okay, in this case, we want to find the rate of disappearance of B. However, B is a product. B does not disappear. B is formed instead. They don't agree. That's why there's a negative sign in front of the number. And then don't forget, you must multiply with the stoichiometric coefficient ratio. So the ratio for B is 2, the stoichiometric coefficient. For A is 1. So it becomes 2/1. So 2 lah kan? Multiply with your minus RA. So then you will get minus RB as negative 0.096. Okay, so as I mentioned, okay, soalan Part A is something that I've covered in the lecture, but part B is something extra that you combine the knowledge that you have learned in chapter 1 before. Okay, so I will give you about 2-3 minutes as usual for you to go through it. Okay, if you have a calculator, you can try to press calculator just to familiarize yourself with the question. I will come back in 3 minutes for me to continue the next question. Okay, all right. So we are back. So we'll go to the next question, question number 2. So question number 1 is basically using differential method. So let's go to question number 2. So the question number 2, The gas phase decomposition to produce B and C was conducted in a batch reactor at 70 Celsius. So if you wonder kenapa in all these chapter 5 method, we will use batch reactor. So I told you, right, normally that's why the importance of batch reactors. But bila we have new reaction or when we modify the reaction, there are very high probability that you will have the difference in the reaction order and the difference of the value of key. So in the case when we want to establish this data, we will conduct the experiment or the reaction in a batch reactor to obtain this data. Okay, sebab tu kalau kita ada soalan kenapa it's always in a batch reactor, it's purely because to gather the information, we will run it in a batch reactor. So the following concentration time data was obtained. So again, data dia time atau time versus concentration. So for sure bukan half-life method lah. Definitely is either differential or integral method. Okay, so next dia kata the following plot of 1 per CA versus time was obtained from the data above. From the plot, the gradient was determined as 4.47 with a y-intercept of 179.95. Okay, so from these two lines, ada two information. First, dia beritahu kita plot dia. Okay, so the plot is 1 per CA versus time. So definitely dah bukan differential method lah. Kalau differential method, it must be negative, ln negative dCA per dt versus ln CA not. Ln CA, sorry. So this is definitely not differential method. So that means it is integral method. Okay, tapi integral method pula, kalau you remember, we have separate equation kan, because separate equation for different reaction order. Meaning, kalau zero order, it have its own equation. First order is own equation, second order is own equation, and then from the equation 2, we will plot. We have to check the plot and then we verify whether the plot fulfills the requirement. Okay, baru kita boleh cakap betul tak reaction itu adalah, let's say, zero order, first order, second order. So in this case, it is already somewhat easier for us sebab dia dah beritahu kita plot dia berdasarkan 1 per CA versus time. So if you remember, okay, kalau tak remember pun tak apa, you can always check the notes, okay. There's only one equation of which the plot is 1 per CA versus time. Okay, so the plot is for second order reaction. Okay, kalau dia first order, zero order, you will plot CA versus time. Kalau first order, you will plot ln CA not per CA versus time. Only second order, you will plot 1 per CA versus time. Okay, so that's why I know it's a second order plot. However, okay, tu kita dah tahu dulu. Okay, we will deduce later as we see the question apa yang dia nak. Okay, then second, dia beri information about the gradient, slope dia lah. So the slope is 4.47, the y-axis intercept 179.95. Okay, so the first question says, determine reaction order and the specific reaction rate constant. Nak cari alpha, nak cari K. Okay, so I told you, kita dah tahu this is a second order plot. Okay, so then you go and look. Equation untuk second order reaction, what is the equation in the integral method? So the equation is given as 1 per CA equals to KT plus 1 per CA naught. Okay, so kita kena first from equation, yang penting tengok dulu. Tahu dulu apa data for y-axis, apa data x-axis, dan kita boleh tahu gradient tu adalah apa, y-intercept tu adalah apa. So in this case, your y-intercept is 1 per CA. So your time will be your x-axis. Okay, betul lah daripada plot kan. Y-axis kita kan 1 per CA, x-axis kita kan time. So K should be my gradient or my slope. 1 per CA naught is my y-intercept. Okay, itu kita dah faham. Tapi sebelum kita nak betul-betul conclude dia adalah second order reaction, you have to check the plot. The plot has to fulfill two requirements. Okay, so you remember what was the requirement? First, the plot must have a positive gradient ataupun positive gradient of with a straight line. Okay, so kita tengok plot ni betul lah dia straight line. Okay. Second, gradient dia 4.47 is a positive gradient. Betul lah. Okay, so the first requirement, correct. Second requirement is the plot must have a y-intercept. Okay, so remember dalam from the what we learned, kita tahu that the plot untuk if it's a second order reaction plot, dia mesti ada y-intercept. So you check the plot, we do indeed has a y-intercept of the plot. So we can conclude that the plot fulfills the requirement of a second order plot. Hence, we can conclude that the reaction is second order with respect to A. And we can also say that, kejap saya besarkan. And we can also say that, therefore, alpha is 2. Okay, second order. So that's why you can write down the rate law. Rate law dia akan menjadi minus RA equals to KCA power of 2. Sebab dia adalah second order with respect to A. So done. Okay, straightforward. Next, dia nak cari specific reaction rate constant, K. So daripada the plot, okay, we know that your slope, your gradient is your K. So direct lah. The gradient is given as 4.47. Okay, so you can write the K as 4.47. So in my case, saya tulis subscript 70 ni untuk ingatkan saya bahawa this K is at the reaction temperature of 70 Celsius. So you must remember nak tulis the subscript 70 tu tak tulis pun tak apa. Just that I write it so that I remember that this value of K is exclusively only at the 70 Celsius, which is the reaction temperature, and is equal to 4.47. So again, the unit you have to check. This is second order reaction. Second order reaction, dimension K is 1 per concentration time. So maksudnya unit dia kamu kena check. Kalau concentration from the experimental data, my concentration unit is mole per dm cube. My unit of time is minute. Hence, the unit of my K becomes dm cube per mole minute. Okay, kenapa? Sebab 1 per concentration time, kan? So dapat 4.47 dm cube per mole minute. Okay, so you can see question A very straightforward. Just that kamu kena faham kalau plot ni untuk reaction order mana. Then dah tahu equation dia, kena verify. Does the plot fulfills, does the experimental data yang kamu plot tu fulfills the requirement of the plot? If yes, then you can conclude it is second order. Then lepas tu barulah kamu boleh cari nilai K. So next one, let's go to the next question. So next question dah panjang sikit. Okay, so a new run is conducted at 50 Celsius. So kamu imagine, tadi saya run experimental data tu, I run at 70 Celsius. So this whole set of information yang time versus concentration ni, this I obtain at 70 Celsius. Tapi dalam soalan B, dia kata sekarang saya dah run pada suhu yang baru 50 Celsius. So in your mind, just remember the change of temperature affects the value of K. So kalau dia affects value of K, dia akan juga affects your rate law, your minus RA. Kalau dia affects minus RA, dia juga akan affects your reactor design. So for example, nak cari reaction time ke, nak cari volume ke, dia mesti akan already affected. Okay, so you have to understand how it affected the calculation. Okay, so next one, dia kata, given the rate of disappearance of product C as negative 0.70 with outlet concentration, with its outlet concentration of 4 mole per dm cube and 80% conversion of A. Calculate the activation energy in calorie per mole. Okay, so banyak information kita kena synthesize ini. Okay, so we go slowly one by one. Okay, so first of all, let us try to synthesize sentence 2. Sentence 2 says, rate of disappearance of product C as negative 0.70. So maksudnya, rate of disappearance negative R kan? This is for product C. So negative RC, negative 0.70. So you find this a bit weird kan? Biasa kita tahu minus RA. Tapi dalam kes ni dia beri kita information minus RC, negative 0.70. Okay, next dia kata its outlet concentration of 4. So dia kata produk C punya outlet concentration. So meaning C subscript C, CC, 4 mole per dm cube. So kenapa C subscript 3? outlet concentration of product C. So you find this a bit weird kan, dia bagi minus RC, dia beri kita CC. Okay, tak apa, kita tengok lagi. Next dia kata 80% conversion of A. So X is 0.8. Okay, so you want us to find activation energy. Okay, so kita nak cari activation energy. Alright, so in order to do this, maybe you wonder how do we start? Okay, so again I will tell you, tengok apa yang dia nak dulu. Dia nak activation energy, EA. So kamu dah tahu kan, kalau EA dia mesti daripada Arrhenius equation, dia tak boleh lari. Okay, mesti Arrhenius. Tetapi cabaran dia adalah Arrhenius kita ada dua version kan. Okay, version pertama yang tadi kita dah belajar, the one that we have used previously. This one I go up a little bit. This was what we learned, we used previously. This is Arrhenius. Okay, so katakanlah kita rasa kita boleh guna, this is a possible equation to solve sebab ada EA kan. Okay, then you think back. In order for me to use this, kan kita nak cari EA, the rest kita kena cari kan. Okay, so first K, kita kena tahu K. So kita tak tahu K pada 70. That's one challenge. Okay. Second challenge is, okay, temperature kita tahulah. We know the temperature. We don't know K at 70. One challenge. And then we also don't know A. Okay, so biasanya untuk cara yang paling senang saya nak terangkan, when you have two Arrhenius equation and if you don't have A ataupun which is the pre-exponential factor or frequency factor, very unlikely you will use this first version of the equations. But first version ni mesti kena ada pre-exponential factor ataupun frequency factor. Since dalam part A punya soalan tadi, dia beri kita frequency factor. Sebab tu kita guna equation version pertama. But in our question number 2, the B here, we don't have frequency factor. So if you don't have frequency factor, very unlikely you can use the first version. Hence, we are left with the second version. Okay, so let us figure out, boleh tak saya guna second version ni? Okay, so in order to use second version, kita tengok balik apa yang kita kena ada, apa yang kita tak ada. Okay, first of all, EA, I want to find, right? Okay, EA tu saya nak cari. R is gas constant, dah tahu. Okay, T1, T2 should not be a problem. Kenapa saya kata tak ada problem? Sebab first of all, saya tahu suhu tindak balas asal saya 70. That can be my T1. Therefore, my neuron at 50 Celsius, that will be my T2. Okay, so then kita tengok pula yang sebelah kiri. K2, K1. Meaning saya kena tahu K2, saya kena tahu K1 kan? Okay, tadi saya kata T1 is at 50 Celsius, right? So the K mestilah juga pada 50 Celsius. So in part A, we already, T1 is 70 Celsius. Sorry, original temperature was 70 Celsius. Meaning if T1 70 Celsius, I must already know K at 70 Celsius kan? K1, T1. So K1, K 70, T1 to 70. Okay, so dalam part A, kita dah tahu K at 70 Celsius. So means K1, T1 saya dah tahu. Okay. Next saya kata T2 must be at 50 Celsius kan, suhu baru. I want to know, I want to find at the new temperature which is 50 Celsius. Meaning kalau T2 50 Celsius, maka K2 must be K at 50 Celsius. So the challenge here pula sangkut pula pada equation ni. Kita dah selesai semua kecuali K at 50. Because without knowing K at 50, sebab kita kan ada K1, T1, K2, T2. Nak cari EA. So I already know K1, T1. I already know T2. I don't know K2, which is K at 50 Celsius. So then you have to think back lah. How do we find K at 50 Celsius? So hence that comes the, you have to then think, information yang diberi ni macam mana kita nak gunakan. They do give us two interesting information yang you don't commonly see. Sebab tu kadang-kadang kalau kamu tengok, kalau soalan tu diberi information yang macam biasanya tak diberi, tiba-tiba soalan ni diberi dan kamu kena faham hint dia, this information must be used. In what way? That is the challenge. Okay, so dia beri kita minus RC dan CC. Okay, now, kalau kamu ingat balik, okay, so we come back lah. Let's say you know, you somewhat faham minus RC tu apa? So RC ni adalah rate of disappearance of C. So kita baru belajar tadi kan, minus RC mesti berkaitan dengan minus RA. Mesti berkaitan kan, kita nak cari minus RC daripada minus RA. Then kamu pun ingat, kalau minus RA tu kan ada value of K. So kamu kena ingat minus RC ni pada suhu baru, pada suhu 50. Okay, then minus RC ni akan dapat minus RA. So minus RA ni pun akan pada suhu 50 Celsius. And in this minus RA, we have the K. So naturally, that K will be the K at 50 Celsius. So the hint is, first, we have to relate from minus RC to get minus RA. And from the minus RA, we can get our K. Okay, so let's say we want to use that sequence of understanding. Okay, so first, how to relate minus RC kepada minus RA. Okay, so we know, kita pun baru belajar tadi, kita cari minus RB, sekarang kita cari minus RC kan. Okay, so minus RC, rate of disappearance of C equals to, again, number dia kena check, negatif ke positif. Okay, dalam this reaction, naturally C is a product. So rate of disappearance of C, but C is a product, C does not disappear, C is formed, hence the number is a negative. Dia tak bersetuju dengan satu sama lain. I want to find rate of disappearance, but my C doesn't disappear, my C is formed. It does not agree, that's why the number has a negative sign. Negative C per A multiply with minus RA. So sebelum ni kamu biasa buat, dapat minus RA, cari minus RC. Sekarang kita terbalik. Kita dah tahu minus RC, kita nak cari minus RA. Kenapa? Sebab minus RA kita tu ada K yang kita nak gunakan, which is K at 50. Okay. So it become your C per A ni, don't forget your ratio of stoichiometric coefficient. In the question, the C per A is 2/1. Okay, 2/1. So become negative 2 multiply with minus RA, this one I make it red for you to understand. So this minus 2 minus RA equals to the minus RC, which is negative 0.70. Dia terbalik. Dia beri kita minus RC tu negative 0.70. Kita nak cari minus RA dahulu. Okay, so from this correlation, you will get your minus RA as 0.35. So kenapa kalau kamu terfikir kenapa minus RA itu positif? Just remember, minus RA ialah rate of disappearance of A. In reaction, A will always disappear sebab A adalah reactant kan, so dia agree to one another. That's why minus RA is always a positive number. Dia takkan pernah jadi negatif sebab A is always a reactant. A will always disappear. Okay. So now I get ready minus RA. Tadi ingat kan kita cari minus RA for minus RC. And for minus RA, we want to find the K at 50 Celsius sebab minus RC is at 50 Celsius. Therefore, minus RA pun at 50 Celsius. Therefore, the K pun akan menjadi K pada 50 Celsius. So let us now tengok pula how to find the minus RA. Nak cari K daripada the minus RA kan. Okay, so on part A, kita dah establish reaction dia second order. So rate law dia minus RA per KCA power of 2, second order. Okay, so equals minus RA KCA power of 2. So minus RA kita dah tahu, we calculated 0.35, done. Okay, so right hand side K50 kita nak cari. So kita nak cari, kita biarkanlah, that is the unknown that we want to find, right? So we leave it. So next one, CA power of 2. Okay, so by right kita kena tahulah CA tu. Okay, sekarang kita sangkut pula. We do not know the CA at 50 Celsius. We do not know the CA. Kita tak tahu outlet concentration of A. So sekarang kita sangkut sikit pula. Kita tak tahu outlet concentration of A at 50 Celsius. However, okay, then you have to remember back. Kita kan boleh express CA in the form of CA0 and X. Sebab kalau kamu perasan, the question give us X. Okay, so maksudnya instead of finding CA, which we don't have, we can correlate that CA, kalau kamu still remember, in chapter 3, I taught you we can find the concentration of A equals to Ca0 in bracket 1 minus X. This is liquid phase, batch reactor liquid phase. Ca equals to Ca0 in bracket 1 minus X. This one dalam chapter 3. So macam kamu kena repeat balik, kamu kena ingat balik. Chapter 3 kita dah belajar. Ca equals to Ca0 in bracket 1 minus X. So if you have Ca power of 2, so become Ca0 power of 2 in bracket 1 minus X power of 2. Okay, so sekarang dia jadi lebih panjang sikit kan. Tadi Kca square. Tapi masalahnya Ca tak tahu. Ca tak tahu kena terbitkan dalam bentuk Ca0 1 minus X square. Okay, so let us look back. X kita dah tahu. X we know. The question given as 0.8. So X settled. Then come the next problem pula. Ca0. So actually tak solve lagi juga. Sebab sekarang kita tak tahu Ca0 pula. Okay, so tadi tak tahu Ca. Dah terbitkan dalam bentuk Ca0X. X dah settle. Ca0 pula tak tahu. Okay, however, kamu kena tengok balik. Apa lagi information yang kamu tak guna? So you always remember, all information has a purpose. So one more information that you haven't used yet is Cc. Remember they tell you the outlet concentration of C is 4. So by right, if you remember, from the outlet concentration Cc, you can actually find Ca0. There are the correlation there. So kalau remember, in chapter 3 pula, they correlate. Cc equals to C per A Ca0X. Tak apa, kalau kamu rasa macam tak ingat, don't forget, ada dalam chapter 3, kita dah express concentration dia. So, outlet concentration of C will be equals to C per A Ca0X. So, kalau kamu perasan, Cc I already know, which is 4. C per A is 2/1. X is 0.8. So, I can get my Ca0. So, dalam kes ni, tak tahu Ca, terbitkan dalam bentuk Ca0. Tak tahu Ca0, kebetulan kita ada information pasal Cc. We use that information to find the Ca0 first. So then you will get your Ca0 from this equation as 2.5. Okay, so dah dapat 2.5, baru come back to the equation previously. Replace your Ca0 with 2.5. Then only you will get your K at the new temperature, which is 1.5, K at 50 Celsius. Dah dapat K pada 50 Celsius, so sekarang kita dah boleh solve lah. We already know K1, K at 70 Celsius. I also already know K at 50 Celsius. Then only I can solve the Arrhenius equation, K1 T1, K2 T2, in order for me to get my EA, and you will get the answer as 12,789.60. So, combination K1, T1, K2, T2, kamu tak payah bimbang. If you say you want to use K1, katakan K pada 50 as your K1, T1, then you use K at 70 as your K2, T2 pun boleh. Either one sequence pun kamu guna, you will still get the same EA. Macam saya guna K1 at 70, K2 at 50. Katakan kamu terbalik, kamu guna K1 at 50, K2 at 70 pun tak apa. But make sure you replace correctly in the equation. So equation dia kata mesti K2 equals to K1 exponential EA per R in bracket 1 per T1 minus 1 per T2. As long as you use the correct sequence, okay, either one pun, you will get the same EA answer. Okay, so this is how to solve for question B. I admit dia bukan straightforward. Okay, so even tutorial I did try to let you do question yang mana memang tak straightforward lah. So you really have to understand step by step. Dia tak beritahu kamu directly apa yang kamu kena cari. So kamu kena betul-betul faham information ni apa yang saya boleh dapat and how this information can be correlated for the next equation and then to the next equation and then the equation doesn't come only from one chapter. The equation comes from all the chapters. As I told you, the chapters cannot be learned in isolation. You have to actually read all the chapters together, baru kamu faham macam mana dia boleh correlate. Okay, so as usual, I will give you maybe about 3-4 minutes. As usual, please try to look back at it, okay, understand, and then we will go to the last question. Okay, so I will come back in about 3 or 4 minutes. Right, so we are back. So we will do the last question, then we are done for today. Okay, so before I forget, next week we won't have any class. So the class for next week, you're free from any class next week. Okay, so we will continue on week. This is week 9, week 10, week 11, we will come back lah. Okay, so don't worry. Okay, je, because we left only with 3 chapters, and chapter 6 a little bit of calculation lah. 7 and 8 is very easy. It's just a reading chapter, so we should be able to finish everything in week 12 the most. Okay. So the question says, all right, let me make it big first. Okay, the gas phase reaction is as shown below. The experimental runs were performed in an isothermal isobaric constant volume batch reactor with 10 kJ per mole activation energy. So dalam soalan ni, they give us the activation energy EA 10 kJ per mole. The following plot of ln T half versus ln CA0 was obtained from the data shown in table. From the plot, the gradient was determined as negative 0.64 with a y-axis intercept of 1.75. Okay, so in this question, experimental data dia, plot dia. Okay, so the plot is in the form of ln T half versus ln CA0. The data in the form of CA dengan half-life. So you terus tahulah kan kalau data tu dalam bentuk half-life, definitely it is a half-life method. Dia dah tak boleh jadi method lain sebab only half-life method will have the plot of ataupun akan ada experimental data in the form of half-life. Okay, so kalau kamu ingat nak memahami data eksperimen ni, maksud dia they run 6 different run. Each run they prepare a new concentration of A. So for example run 1 they start dengan concentration A tu 16.67. Okay, lepas tu dia read the reaction run, dia akan record masa that how long it takes for this 16.67 to become half of its value. So katakan about 8 point something ke 8.3 something. So it takes about 1.2 minute. Okay, so done, habis. Dia masukkan untuk run kedua, new reactant. So reactant ni let's say 7.71. Okay, dia record masa how long it takes from 7.71 to become half of its value. So dia repeat lagi. So from there, they plot a graph. So we are lucky enough lah, we don't have to plot the graph in the tutorial. So from the plot, we will have the equation. Okay, so kamu kena tengok equation lah. Half-life method satu je equation. So the equation is given as ln T half equals to in bracket 1 minus alpha ln CA0 plus ln 2 power alpha minus 1 per K alpha minus 1. So half-life method ni memang equation dia panjang. Okay, so from the plot, okay, let us see the question first. The question says, as usual lah, find reaction order alpha and the specific reaction rate constant K. Kita nak cari alpha, kita nak cari K. Alright, so from the equation, you naturally has to know lah which one y-axis, x-axis. Okay, so y-axis is naturally ln T half. So x-axis naturally ln CA0 to x-axis. Hence, 1 minus alpha will be your gradient lah. Y equals to mx plus c. So 1 minus alpha is your gradient or your slope. And the back part yang panjang-panjang ni, the ln 2 power alpha minus 1, so on and so forth. This one is your y-intercept. Okay, so we do one by one lah. So we know from the question, the gradient is negative 0.64. So you can see lah slope dia memang kecurangan negatif. Okay, so the gradient negative 0.64 equals to 1 minus alpha. So be very careful dalam soalan ni. You really have to check equation, tengok gradient dia equals to what. So m gradient equals to 1 minus alpha equals to negative 0.64 as given by the question. Hence, you will get your alpha as 1.64. Be very careful of the negative sign. Okay, this one also sometimes student might make a little bit mistake. The negative positive tu, be very careful. So you will get your alpha as 1.64. Round up to the nearest integer, jadi second order. So this reaction is actually second order reaction. Rate law dia minus RA equals to KCA square, power of 2 sebab second order. Done. Next, nak cari K. So nak cari K, be very careful. The K will comes from the back part of the equation because we know ln 2 power alpha minus 1 per K alpha minus 1 in bracket equals to your y-intercept, which is 1.75 as given in the question. Okay, so dalam contoh ni means kamu dah tahu alpha kan? We know alpha is 1.64. So you replace your alpha, you use the alpha before round up. Okay, untuk pengiraan nak cari K ni, kita gunakan alpha yang sebelum kita round up to the nearest integer. So alpha 1.64. So you are left only with K, right? So you can find your K. So your K is actually 0.1516. And because this is second order reaction, so the dimension is 1 per concentration time. Okay, dalam from the experimental data, concentration is mole per liter and the unit for time is minute. Sebab tu dia jadi liter per mole minute, the unit for your value of K. Okay. So this question memang tak susah. However, there are tendency for students to make mistakes untuk cari nilai K ini. So please, when you have spare time, nanti kemudian saya beri a little bit of time, please try to press your calculator in order to solve this equation to find your K. Okay, sebab part ni ada melibatkan ln, ada melibatkan power, and sometimes I realize in the previous semesters, student have a little bit, mungkin I think it's silly mistake je lah, dia salah tekan calculator, they are not able to get the value of K. So later when you have time, you try, see dapat tak jawapan K yang sama dengan jawapan dalam soalan ini. Okay, so done for part A, not difficult, just that kena tahu equation, kena tahu what part represents the slope, what part represents y-intercept, and how this information kita guna untuk find alpha and K. Okay, so we go to a more difficult part, part B. When the reaction in run 4 was repeated at the new temperature of 50 Celsius, it took 18 minutes longer to achieve the same conversion of 80%. Determine the original temperature of the experimental runs. So question dia macam pelik kan? So the question is something that you are not so familiar. So let us understand again. Dia kata, reaction run 4. Okay, kita kan half-life method kan kita ada banyak. Kita kena buat different run, right? So dia talking about run 4 ni dia repeat balik run 4 ni. Tetapi run 4 ni means dia akan menggunakan CA0 1.78. They will still use the CA0 of 1.78. Dia run again the experiment. And dia kata tapi eksperimen yang run 4 ni di mana CA0 dia 1.78, they will run at new temperature of 50 Celsius. Dia run balik tapi dia run pada 50 Celsius. And dia kata bila saya run balik run 4 ni yang CA0 1.78 pada suhu baru 50 Celsius, the reaction takes 18 minutes longer to achieve conversion 80%. So run 4 saya run pada suhu baru, saya dapati yang I found that it takes me 18 minit lebih lama untuk mencapai conversion 80% berbanding eksperimen yang sebelumnya. Okay, so katakan eksperimen sebelumnya ambil masa 30 minit. Okay. Sekarang bila saya run balik eksperimen 4 ni, saya tukar suhu, dia lebih daripada 18, dia mengambil masa 18 minit lebih lama. Maksudnya 30 tambah 18. Katakan run pertama ambil masa 30 minit. Run kedua ni pada suhu baru dia akan mengambil masa 48 minit. 18 minit tambahan daripada the run that runs on previously. Okay. So lepas tu dia kata, dia tanya, determine the original temperature of the experimental run. So dia tanya sekarang, apakah suhu asal tindak balas kita? Okay, so yang run yang kita run ni, yang kita plot graph ni, run ni kita sebenarnya tak tahu suhu dia because you write in the reaction, in the question, they did not tell us this experiment is run at what temperature. Sebab tu sekali nak tahu apakah temperature of this original run. Okay, based on the information diberi, kalau saya run pada suhu baru untuk run 4, saya akan ambil 18 minit lebih lama. Okay, so how do we solve this? This is quite a difficult question, right? Okay, so again, come back. Bila masa ada soalan yang melibatkan temperature, kamu tahu kan, kalau senang sekali nak tahu kalau beri kamu EA, kan dia beri kita EA 10 kJ per mole, definitely akan menggunakan Arrhenius equation. Okay, so cabaran kedua macam saya kata tadi, Arrhenius ada dua version kan, version yang ada pre-exponential factor atau version yang tak menggunakan pre-exponential factor. Evidently dalam soalan ni tak ada pre-exponential factor. Kalau tak ada pre-exponential factor, of course lah the first version of the equation tak boleh guna. So definitely kena guna second version. Okay, so dalam second version tu kamu ingat kan, dia kan ada K2, K1, T2, T1. Kan biasa kan? So dalam soalan ni, dia nak cari T1, dia nak cari original temperature. Okay, so kita tahu equation ni K2, K1, T1, T2, K1, K2, EA kita tahu 10 kJ per mole. Okay, kita nak cari T1, the original temperature. T2 kita dah tahu because the new temperature is 50 Celsius. So T2 saya dah tahu, T1 saya nak cari. Sekarang saya tinggal K1, K2. Okay, macam mana kita nak buat? Okay. K1 kita dah tahu sebab ni kan kita cari daripada from the part A, kita dah tahu K1. Kita dah tahu nilai K. K1 tu kita dah tahu tapi kita tak tahu T1. So K1 kita dah tahu daripada part A. Okay, done. K2. Okay. Sekarang masalahnya kita tak tahu K2. K1 dah tahu, T2 dah tahu, EA dah tahu, tak tahu K2. Kalau tak tahu K2, still tak dapat kita punya T1 kan. So kalau kamu tak boleh imagine, kamu tengok equation yang bawah ni. Kamu imagine sekarang saya dah ada, mungkin ni kamu tak dapat sangat. Saya pergi atas, kita tengok yang equation ni. So kamu nampak? T1 I want to find. T2 is 50 Celsius. K1 was from part A. Part A saya dah tahu K1. Sekarang saya kena cari K2. Tanpa K2 saya takkan dapat T1. Okay, so how to find K2? Then kamu kena tengok. Sebab tu dia beri kamu information yang pelik kan. Dia beritahu kamu it took 80 minutes longer to achieve the same conversion of 80%. Maksudnya, in order for me to find K2, saya kena menggunakan information yang berkaitan dengan reaction time. Okay, dia beritahu kita 80 minutes longer to achieve the same conversion. Maksudnya kamu kena faham, kita akan menggunakan equation yang berkaitan dengan reaction time. Okay, kamu kena faham, ia tak ada kaitan dengan half-life. Walaupun kita diberi information mengenai half-life, but from the experimental data, but this experimental data, half-life ni adalah berkaitan dengan masa taken for the concentration to become half. Okay, when we want to talk about reaction time, dia tak berkaitan dengan half-life. Okay, so you have to remember untuk reaction time, kalau batch reactor, we have already learned in chapter 4 the equation to relate reaction time. Okay, maksudnya, katakan, in order for me to find K2, saya kena guna equation yang berkaitan dengan reaction time. Sebab dia beritahu kita tindak balas tu suhu baru akan mengambil masa 18 minit lebih lama. Okay. So maksudnya kalau saya boleh cari the reaction time for the original reaction, lepas tu saya boleh cari untuk the reaction time for the new temperature, I can find my K. Ataupun cara saya nak terangkan, if you see this equation, kamu kena ingatlah, kamu kena tengok notes chapter 4, ada equation to correlate reaction time untuk batch reactor second order reaction. So the equation is given as reaction time equals to 1 per KCA0 X per 1 minus X. Maksudnya, kalau kamu faham equation ni, okay, saya tahu X 80%, 0.8, okay. Saya tahu K1 sebab daripada part A saya dah tahu K pada original temperature. And saya boleh cari juga CA0 sebab saya tahu CA0 ni daripada run 4. Dia katakan kita repeat run 4. Daripada experimental data, run 4 is 1.78. Okay, so kalau saya boleh tahu information ni, saya boleh cari original reaction time dahulu. Kalau saya dah dapat original reaction time, saya boleh cari reaction time pada suhu yang baru. Kalau saya dah tahu reaction time pada suhu yang baru, saya boleh cari K pada suhu baru. Okay, again I repeat. Kalau saya dah tahu from the reaction time equation, I can find the reaction time for the original run. Sebab saya tahu K1 from part A, saya tahu CA0 sebab dia adalah run 4, and saya dah tahu conversion dia 0.8. Okay, katakan saya kira ni, I get from my original temperature, the reaction time is 14.82 minit. Okay, run yang original pada suhu yang kita tak tahu tu originally, it takes 14.82 minit. Okay, lepas tu, pada run yang baru ni kan dia ambil masa 18 minit lebih lama, so it become 18 plus 14.82, which is 32.82. So sekarang, my reaction time at the new temperature is 32.82 minutes. Why? Because it takes 18 minutes longer than the original temperature run. Okay, now Kalau saya dah tahu T2, which is at the new temperature, saya dah boleh carilah K yang pada suhu baru. Okay, so maksudnya dia macam, how do I say, suhu asal dapatkan masa, masa tu tambahan masa untuk dapat masa yang baru. Pada masa baru tu dapatkan K yang baru. Okay, kenapa K tu berubah? Sebab suhu berubah. Yang lain semua tak akan berubah. Maksudnya T2 32.82, K changes for the new reaction temperature. My CA0 is still 1.78 sebab dia kata dia repeat experiment 4. Dia repeat run 4. Run 4 tu the CA0 is 1.78. Then the CA0, the X is still 0.8 sebab dia kata soalan dia kata same conversion. So from the new reaction time, you will get the new K at 50 Celsius, which is 0.0684. So now I know K1, K2, T2, I know EA, then only I can find my T1 using the Arrhenius equation, the one that we discussed previously. Okay, so then you get the original temperature as 411.04 Kelvin, or in Celsius is about, kejap saya tengok, 411.04 minus 273.15. The original temperature is 137.89. Okay, so that was the original temperature for the original run. Then the second run, the new temperature 50 Celsius. Okay, so not to confuse you, but you can see the correlation. Original temperature lebih tinggi daripada the new temperature. Sebab tu masa tindak balas takes longer. Kan kamu ingat, lebih meningkat suhu, masa menjadi lebih singkat. When you increase temperature, reaction time become shorter. So dalam ni kamu nampak, when the temperature decrease, sebab tu masa tindak balas menjadi lebih lama. Because my original temperature is about 137 Celsius. I lower down to 50 Celsius. So temperature decrease, time become longer. Daripada tadi 14 minutes, dia become 18 minutes longer, it become 32 minutes. So dia buat terbalik lah, reciprocal effect. Okay, so that's for question number B. So I understand the question can be a bit confusing sebab kamu kena faham konsep reaction time. Kamu kena faham dalam chapter 4, kita dah derive reaction time. And then kamu kena faham konsep apakah maksud dia when I say the reaction takes longer time. Apa maksud dia? And then how you correlate to find the unknown in the question. And also, I understand if you might get confused dengan half-life punya information. Half-life tu is just time taken for the original concentration to become half of the its original concentration. Dia tak berkait atau dia adalah sama sekali tak sama dengan reaction time. Reaction time ni konsep dia berdasarkan conversion, berdasarkan the key value, berdasarkan the initial concentration. So you have to differentiate that understanding of the information. Okay, so that's all for today. Maybe as I thought, I will make it a little bit small for you to look again. Okay, so that's all for today class. We finished a little bit earlier. So you have a 1 week break next week. So use the time, spend the time with your family. So before I leave, probably it's a little bit too early. I mean less than 1 week lah. So probably I can already wish for those yang menyambut Raya, Selamat Hari Raya, Aidilfitri, and I hope you have a good time with your family and your loved ones. So I will see you back in the following week after Raya. Okay, so that's all for today. Thank you, everyone.
Thank you, madam.
Thank you.